So this is going to be day 11 of Workshop Wasteland's Tricks or Treats, and this is a bit of like a niche video. It's probably not something that everyone's doing, but it's still pretty interesting. And it's the focus of today's video is making and heat treating piston rings. So there's a whole article in the Home Shop Machinist in the January-February 2018 catalog, or magazine rather. And this article is by Ted Hansen, and he walks you through exactly everything that you need to do to make and heat treat piston rings. And I just did it for my model that I'm building, my 6-cycle oddball. I'll try and put the link to that up there somewhere if you want to go check it out. I'm almost complete, so you could go back and watch all of the videos. But interestingly enough, I've made piston rings in the past, and they worked okay, but I could never keep them round. And honestly, I think it had a lot to do with not heating them uniformly or getting the entire piston ring to the same temperature and holding it there. So what's clever about Mr. Ted Hansen's whole setup here is that you basically create like a little oven, if you will, or a little heat treating chamber, I guess you could call it, and it heats the entire piston ring up uniformly. So you can see down here at the bottom of that picture, that's kind of what the heat treating oven looks like. And this is what I came up with. I'm going to take this apart in a second and show you. But basically, you make a piston ring, literally a ring out of cast iron. Of course, it's very thin. It's a super basic lathe operation. You machine the OD, plunge into the cast iron to machine the ID of this ring, and then you put it, or what I do is I put it in my machinist vise and clamp it like this, and then take a chisel, give it a little whack, and it'll break off. And then you heat treat them with a little spacer block, and what you end up with is an almost perfect piston ring. I mean, this is really well. It's nice and springy. It is exactly to the dimensions that I need, and I tested them in the engine that I'm building, and I have fantastic compression. So I'm very happy about that. Let me take this stuff apart and give you a little bit closer look at kind of exactly what you need and show you just some of the work that's involved in something as simple as 2 piston rings, because that's what I needed, right? 2 piston rings for the piston of this engine. And while that sounds super easy, and it is easy, it was just time consuming to make all of the parts and pieces that were needed and then accurately machine these piston rings and be able to finish them out so that you have something usable in the end. And I did get very usable piston rings. So let's check this out. I think it's pretty darn cool. Like I said, it's kind of a niche video, but continue watching. You'll think it's neat too, I'm sure of it, even if you have no plans of making piston rings. Or who knows, maybe someday down the road you'll be interested in it and this will come in handy. So let's check it out. Also, don't forget to subscribe. Like I said, this is day 11. To be honest, I'm kind of running out of ideas. I'm going to try and keep this going, but no promises. Alright, so first and foremost, this is just kind of some cliff notes from that article. So the thickness of the ring needs to be the bore diameter divided by 1/25 or 1/30. And in my case, I came up with that would mean 30 thousandths piston rings, so 30 thousandths wide. But I ended up going a little bit thicker. I know that kind of goes against the rules of what we were doing here, but what I did was went 45 thousandths. And the reason I did that is I could end up making a basically square piston ring based off of the groove that I already had cut. The OD about 2 thousandths over bore. I went about 2.5 thousandths, and that's just kind of where it landed to the best of my measuring abilities. ID to obtain the ring thickness. So, you know, you have to take the OD and the ID, and then that's going to give you how thick of a ring you need it to be. And again, I landed at about 45 thousandths. So that's why I went a little bit bigger here on my width of the ring, because that's what I wanted it to be. Gap the ring 4 times the ring thickness. So I didn't personally do that. I gapped them. They got about 3 thousandths, 4 thousandths, something like that gap. And then you heat to 1,000 degrees Fahrenheit for 5 minutes. My bore after boring it ended up being 764. So the ring OD is 766. That's what I came up with. And then, like I said in this article, it breaks everything down and shows you really exactly what you need to do. You make this heat treating chamber, put a little piece of paper in there to help burn off some of the oxygen so that it can't carburize so bad. I didn't personally do this, but this is a whole lapping fixture that you're going to make, you know, per cylinder. So if you have a 1-inch cylinder, you'll make this 1-inch, basically imitation cylinder, if you will, and lap the rings in. I didn't personally do that. They seem to have great compression, so I think all is well there. And then this is a fixture that you make to grind them down smooth, which was this piece of metal. And then, you know, you just do some figure eights on some sandpaper and clean up your edges after you part this off, because it's going to leave a little bit of a ragged edge. And this is very accurately bored. The ring fits nice and snug in there, and then you could clean off both edges, get them nice and square. Then here's my little firebox. This is what I came up with. His has a bunch of washers and things to be able to clamp your rings down and keep them square. This is bored out larger than my ring. So you can see there, that's what it looks like with the ring inside of it. And then this fits very snugly in there. It's less now that it's been heated up to 1,000 degrees, but it was a pretty darn almost press fit. And I machined out a pocket in that so that what you do, this is a little piece of metal that I had my rings on to space them open. They have a little bit of a spring to them now, so it's not going to work so good to demonstrate, but you'll get the idea. So that little piece of metal was in there like that. And then whenever I put this piece down onto there, what that did was kept the rings clamped nice and square against that face. And then, like I said, you heat them up to 1,000 degrees. I did 3 of them. I only needed 2. I'm glad that I made 3 because one of them developed a little bit of a crack right here and a piece broke out, which made the gap too big. But as you can see, these are very, very functional rings. I could not be happier with them. They fit great in the cylinder. They fit great on the piston. I don't even know if you're going to be able to see that in the camera. At the top up there is my ring gap. You might be able to see that. I kind of doubt it though. This camera doesn't do great with close-up shots, but you get the idea. So like I said, overall, following those plans has worked, I mean, for real perfectly. Couldn't be happier about that. And like I said, this is the January-February 2018 of the Home Shop Machinist magazine, which if you're not subscribed to that magazine, there is some really cool stuff in there. I think you can go back online and find previous versions of that magazine and, you know, be able to see things like this that have been posted in the past. So hopefully you found this useful. If you haven't clicked subscribe, please do so. Otherwise, we'll see you in the next video, hopefully tomorrow. Thanks for watching.